Okay. So, continuing from where we stopped, National Building Code gives you gives you fire separation values. I have just picked up a portion of the National Building Code once. For example, if it is structural element, if it is structural element of wall and it is load bearing, right, it is load bearing, B stands for load bearing, the minimum fire separation should be 3 meters. 3 meters, if the minimum fire separation, not minimum, if the fire separation is less than 3 meters or equals to 3 meters, you need for type 1 construction 4 hours of fire rating. So, what it does, it defines type 1, type 2, type 3, type 4 constructions. 4 types of constructions are defined: type 1, type 2, type 3, type 4. Then it specifies where you should be using only type 1, specifies where you can use type 1, type 2 or type up to type 4. So, you can see that type 1 is that kind of construction where fire resistance is highest. Fire resistance reduces descending manner along this direction, right, and this is load bearing wall, it will have higher fire resistance, exterior wall will have higher values, and interior walls might be having less. If the fire separation is less, you need higher fire resistance. For example, if the fire separation is greater than 3.75, you can reduce down from 2 to 1.5. So, if the fire separation is less, fire resistance is required is high to qualify as type 1 construction. So, type 1 construction, for example, would, if your exterior wall non load bearing, it will require 1.5 hours of fire resistance to qualify as type 1, while exterior non load bearing wall would require 2 hours of fire resistance to qualify as type 1. Also, fire separation goes on to it. So, National Building Code classifies construction into 4 classes: 1, 2, 3, 4. 1 is the one which has higher fire resistance, right, it will have higher fire resistance for all cases, it will have compared to 2, 3, 4, that is 1 fire resistance. And if your fire separation is less, then also you need higher fire resistance. So, type 1, type 2, type 3 and 4 are classified based on fire resistance as well as fire separation and whether it is a structurally load bearing or non load bearing. For a load bearing wall, you will require more fire resistance hours in order to qualify as type 1, while same one, everything else remaining same, type 2 requires only 2 hours fire resistance when it is non load bearing, because structural safety issue is concerned. So, type 1, type 2, type 3. So, it says that okay, where you can have type 1 construction only, you cannot go to type 2. It also says where you can have as well type 4 constructions. For example, a boundary wall, nobody will periphery boundary wall, nobody would bother about it, because its stability is also not much of an issue. So, you might have actually type 4 construction, first it does not matter, while if it is a wall load bearing brickwork and next building is 3 meters and you want to ensure that it should have type 1 construction, then its fire rating must be 4 hours. So, that is what is said. Now, based on this, what is done? It gives you a floor area ratio. So, for example, occupancy group residential, it says if it is type 1 construction, it does not put a restriction on FAR. 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 Only from this consideration, from this consideration, while other consideration you will have FAR restrictions. So, FAR restriction would be, restrictions are always the least of most stringent of all of them. So, from this point from construction, supposing you make everything of type 4 hours construction, 4 hours fire resistance, load bearing, fire separation, etc., you take care. So, residential unlimited, hazardous, it does not want fire to spread, therefore, it keeps it at its floor area ratio is restricted to 2.8. So, therefore, floor area ratio restrictions comes from many things, but this aspect is also one of them from the point of view of planning and fire spread. So, just a residential one does not generate fire, and if you have 4 hours of fire rating in all of these walls, it will not spread fire as well. So, it is saying that okay, as far as this aspect is concerned, fire FAR is not an issue, but if it is a hazardous building, then this is an issue. You can't have even type 1 construction, you can't have more than 2.8 floor area ratio. If it is type 2 construction, it gets reduced further 1.1. That means, because it can, if taller buildings, people will also be there, dangerous situations should be there. So, it does not allow for that, and it does not permit type 4 construction. So, in hazardous building, it does not permit, National Building Code does not permit type 4 construction. Type 3, if it is, then you cannot cover all the areas, right, only 90% of the area in a single story building you can cover, right, and possibly if it is 2-story building, you can make only 55% of the area covered, right, 1.1 is this, and if it is type 1 construction, then fire resistance is 4 hours, fire separation for load bearing wall, not more than 3 meters, etc., etc. So, this is what it is. So, it is another way, indirect way of controlling through floor area ratio for various types of spread of fire and hazard of the fire. This is an instrument which is used for that purpose. So, these are the aspects which goes in planning. These are the aspect goes in planning. Then next aspect is, this is to stop. If you can see, first so far of what we looked into, spread of fire and issues related to firefighting vehicle, initiation and spread of fire and issues related to firefighting also or fire extinction, handling the fire itself. Now, escape and refuge is other most important aspect as far as fire is concerned. Escape and refuge. Now, why it is important? Because people must be safely evacuated before they are in a dangerous condition. They are in a dangerous condition. For example, you must have, if you see, there are 3 terms. First, P, A and RS. So, TP is initiation to perception. This is the time from initiation to perception. What does it mean? Supposing there are no people around, then fire will not be perceived. There is a fire in a building, large building especially, and there are no people near the fire, it will not be perceived. It might be perceived certain period later. But if you have an automatic fire alarm system, fire detection and alarm system, it will perceive the fire, but this also has a lag time. So, it will take some time for fire to be perceived, that I am calling as TP. Then after that, perception to start of escape action. Once the alarm has rang or people have perceived that there is a fire, people will start evacuating, escaping. So, that action would take certain amount of time. So, start of perception to start of escape action. Then this is the time to reach a safe place. So, it will have something like this. If this is time TP, then after that there will be TA, first perceived kiya, first when somebody has you came to know that there is a fire, then you start taking action and then travel to which is safe, right, which could be within the building or outside the building depending upon the situation. Usually safe refuge area for low rise building is outside the building. For high rise building there is no way, you have to have something in the building itself. This should be less than TU. What is actually unacceptable condition? Unacceptable condition, because it could be fatal. It could be fatal or dangerous. So, that is what it is. So, TU stands for initiation to untenable condition, and maybe because of smoke or lesser extent due to heat, because of smoke itself. Smoke is more dangerous. Smoke is more dangerous. So this is, so therefore my escape perception and starting my escape, and this is very, very important. Escape is very, very important. I should be able to go. So escape and refuge is required in taller buildings, right. So this is very, very important. This is very, very important. Now this is a diagram available in David Egan's book, which tells you that as the story height increases, on this axis you have agility of people, occupants, agility, how agile they are. This is athletes and this is confined, bedridden people. Now this is height of the building, this height of the building, this height of the building. So as the story height increases, you see this is escape zone, means agile people, athlete to school age children, they can escape up to 7-story building, up to 7-story building or 7 and 8-story building, somewhere around that, leave the building on their own without any assistance. They can just leave easily. Single-story building, you see a fire, you will straight away run away, and athletes will run away even up to 4-5-story building. Now you see the normal adults, they can run away up to 5-story building maybe. Confined, if released, confined people means jail. They are confined, but if released they can run away, right. So then generally confined, but they can run away. School age people up to 2-story people, they can go away. These people can go possibly up to 3-story. So this is escape zone. I'd rather put it in some other color. This is escape zone, this is escape zone, this is escape zone, right, escape zone. Now people very young, something like 3 years, 4 years, who can't take decision on their own, or very old people who are not able to move so fast, to possibly somewhat differently abled people, right, and stuck to bed. Single-story building up to 2-story building, they must still be able to get out on their own. But as the story height increases, well, they just can't live on their own, but they can live with longer period of time. So this is slow escape zone, leave the building slowly from nearby building, but beyond 7-story building it is difficult for those people to even get out and leave the building on their own, or live to go to a safe place. This is must have, if the story height increases beyond 7 or 8 story, you must provide a refuge zone within the building, because it would be almost impossible to by anybody to get to a safer place outside the building from such building. So it could be another building next door, nearest building, or it could be escape zone within the building. So what you do, the code actually, National Building Code provides you this kind of guidelines. Up to 8-story building, you must have a safe refuge zone somewhere. So you actually do vertical zoning of the building, and this goes well with other kind. For example, lifts also, for vertical transportation you do zoning 8-story. For water supply also you have to do vertical zoning. Otherwise, if there is a tank at the top and it comes, a 60 or 20-story building, same tank supplying water to the ground, well, the pressure will be so high, right. So therefore you do zoning actually, right. So vertical zoning. So refuge zone for up to 8-story or above, you need refuge zone. Move to the safe place within the building itself, and there should be some place where you don't expect much disruption at all. So there you do what is called compartmentation, make compartments. Such compartments are one where fire will not spread from one compartment to the another. So it is a horizontal zoning, each is a compartment. Only thing you can do is, maybe if there is a fire, you provide all protection from fire, if we need like a kind of automatic sprinkler system, alarm system, everything. It should detect, automatic detection system, and alarm that may not play there, play somewhere else, and it should extinguish it itself there, and it should not spread because it will have all fire rated walls. So you can't touch this. For example, hospital intensive care unit, you can't expect people to move out of that. So it should be not 100-150% protected, should have an automatic system of all kinds, alarm system which will ring somewhere else, right. At the same time, it should not get fire from next compartment. So, compartmentation is done, limited compartmentation is done in some places. So, normal occupant zone, safe area must be occupant's normal location, 100% safe, or mentally retarded patients who can't move, take decisions on their own, and not people there all the time at that places. Such places should be, so this is basically confined, mental patients, prisoners who are tied up, let us say, not able to go out, right, such places, and people who are bedridden, people who cannot move, incapacitated, old people or otherwise not able to move. So, these are the people, for them you need safe zone. So, you can see as your agility of the people reduces, you have to height at lower height also you may have to provide all this. And as agility of people, so up to 20-story building, if you can see that 20 beyond, for very young or old people, even in 20-story building you can't expect people to move out. So, that kind of escape and refuge strategy should be adopted in buildings, and that is why the fatality comes because of those kind of scenario. Both now internationally also we are hearing such kind of fatalities. There somewhere the lack of planning part, something is lacking, otherwise this could not have happened. So, minimum, so each zone again I am defining minimum disruption zone where they will remain there. Safe area must be occupant's normal location. Prevent heat intrusion with fire rated construction. Prevents smoke penetration with smoke barriers and pressurization. We will do some of these examples. Manual or automatic suppression system, smoke venting. All these kind of things should be minimal in zone, that is top zone, that is least minimum disruption zone. Refuge area, this next zone, which have some refuge areas provided where occupants can be moved safely within the building. Then you must have adequate number of exits which will lead to that place, and right kind of capacity, number as well as capacity of exit. Fire detection alarm system, so that people can move, and providing condition for safe and gradual movement, and there should be warning system. Move to safe area through protected routes, safe destination within the building itself, that is the next case. And next one, slow escape zone, adequate number of exits, that is the requirement. I must have adequate number of exits and exit capacity so that people can slowly move out. Fire detection, warning and alarm system, escape through the protected route, and safe destination maybe outside the building itself. And this last one obviously requires least, where athletes etc. they can move out on their own, but you must provide adequate exits and exit widths. So, this is important, exits are very, very important, and doorway, corridor, passageway, these are exits, right. For example, this lecture hall we have two exits, one here, one there. Many of the laboratories you will find there is one exit, it is not a very good thing to have, right. You should have at least alternative exits, but this place chances of fire is relatively less. Some of the laboratories where you are, one is doing the chemistry type of thing, there can be burners, some reactions are going on which can exothermic reaction which can generate heat. So, those are the ones. So, essentially you should have escape routes, more than one alternative routes which should be available to people all the time. So, these are the internal or external exits, they lead to internal or external staircases, veranda, tunnels having direct access to the road source street. So, these are the exits actually, doorways, corridor, passageway, these are actually exits which will lead to internal or external staircases through which you can get out, go to the next room. Lifts and escalators are not exits, they are not, and you will find that notice in almost all the lifts that do not use the lift during fire, because lift shaft acts almost like smoke chimneys, so hot gases because of buoyancy convection effect, it will tend to move upward, and it gets filled with smoke. There are something called fire lifts, specific on within fire rated walls, not used ordinarily, but only firemen can use. they are called fire lifts. So, these are not to be used by occupants, only the meant for firefighting people, and all exits should be free from obstruction. That is very, very important. Clear width, you define half exit width. There is some change in the code, but basic concepts remain same, because new code has made some kind of changes related to this. So, 25 centimeter earlier used to be called as half exit width, 50 centimeter is one exit, right. But another way would be just tell it the dimension straight away, the minimum dimension of the exit should be this much. This is based actually on ergonomics. This is based actually on ergonomics, whether I think I do not have diagram, but it is actually based on ergonomics. For example, if this is my width, this is the width. So, space required for a single person to, the space required for a single person, or if you expect wheelchair bound person, then in a ramp, how much is the spacing of a wheelchair? So, how many person can actually move through this? That is based on ergonomics, and this guideline comes from there, this guideline comes from there, and if it is wheelchair bound people, then it requires more, and in a ramp or something of that kind, or even in a corridor, if it is normal adult, then there is required is relatively less compared to wheelchair, but there is a number is is given. So, ideas from the the National Building Code, which was there in the previous one, right, it is something like this, but this is the basis. Suppose total occupant per unit exit width. So, if you have 50 centimeter is a one exit width, half is 25, you cannot have less than, like you cannot have 60 centimeter, it will be then considered only 50. So, it is 50, maximum 70, 75, half you can take 75 centimeter, or it should be in terms of units of 50 centimeter basically, right, multiples of 50 centimeters. Now, occupant load is given in the code in terms of meter square per meter square floor area. For example, for residential building, 12.5 persons per meter square, while in assembly it will be much less. So, occupant load is how many persons per meter square, you want to calculate out the number of persons. So, if it is a classroom or academic like institutional building, then the number would be much less per unit area. So, number of people you want to move around, go to the exit would be much higher. So, occupant load is defined in this manner. For example, 12.5 persons per meter square is for residential floor area. So, if you know the floor area, you can calculate out total number of people there for whom you should provide the exit. So, unit exit width is given by A, D is the occupant density, right, floor area capacity per unit exit width. So, occupant density is what you get, occupant load, that is what you get, meter square per person will be 1 over that, right, 1 over that D, meter square per person. So, it is 12.5 person per meter square per person is 1 over that, you can find out. And C is the capacity per unit exit width, that is the guideline given in the code. So, how many people can, supposing you have 50 people, how much exit width you need, right, or 100 people for a particular area, because supposing this is the room, just outside this is the exit, the corridor. Now, this corridor, if there is another room ending onto that corridor, the total population that would be using that corridor will be sum total of the people here, and you know how many persons would be here, because you know the floor area. So, if you know, the occupant load can be calculated, or occupant density you can find out, meter square per person. Therefore, you know the floor area is known. So, floor area, so if you A is the floor area divided by meter square per person, right, and C is the capacity of unit exit width. So, that will be number of people, actually that has to be number of people, this should be A is the area, D is the meter square per person. So, A by D will give me what, person. A is the meter square divided by, this is meter square per person. So, divided by meter square per person. So, that will give me the number of persons for whom I should provide the exit, and for a C is the capacity per unit exit width. So, if I know for a given type of occupancy, if I know how much is the type of staircase, let us say is 25 person per unit exit width, right, for residential given occupants per unit exit width is given 50 for ramps, 75 for doors. So, these guidelines are given based on ergonomics, as I said, how many people can move around. So, if it is 25, so I have got persons for whom I should provide, divide by 25, you get number of exit width, and each exit width is 50 centimeter. Supposing you get 2.3 exit width, I am just saying hypothetically. So, it will be 2.3 into 50 centimeter, which would make 160, no 130, no 130, which means that you will actually provide 150. You cannot provide anything 25 multiple of 25 at least. So, 150, that is what you will be providing. Is this idea clear? A, these are given in A is the floor area that you know. Occupant load per meter square of floor area, that is given in the code in tabular form. For example, it is 12.5 for residential, for assembly etc. it will be much lower, occupant per unit area. So, if you 1 over that would give you occupant density. If you know the occupant density, area divided by occupant density will give you number of occupant. In unit exit width, how many occupant can pass through, that is given in the code again in tabular. So, this is for residential. I picked up one row of the table which says staircase 25 people, ramps 50 people, and doors 75 people. So, if you divide by that, you get the how many unit of exit width you need, multiplied by 50, that many exit width centimeter, that many centimeter you will get it, that many centimeters, increase it to the nearest multiple of 25, that many. Sometimes the guidelines are given straight away in meters or that kind of thing, depending upon the situation. So, this is the, but idea is like this, basic idea behind this is this. So, this is how you should determine exit width, minimal, right, and maximum distance travelled is also given. So, final exit to get out of this space is also given. So, nothing more than 22.5 meter. Now, if I have a long building, let us say long building blocks 3-4 story blocks, then I must have a, if I have a staircase here and if I have some rooms here, the extreme point I should consider, my travel distance to this place should not be more than 22.5 meters. Now, if I have only 2 staircases here, one there, it might be more. So, I provide external staircases like helical staircases. So, this is that too, educational also 22.5 meters. It also is given by type 1 and type 2 construction. Type 2, in this case it is all same. Some other occupancies it could be different. Since this is more fire resistant, more stringent sort of situation, this will have less distance required, more distance required, this will have somewhat less because type 3 or 4. So, this is the other part of planning, So, for dead end corridors minimum this should be 22.5. So, you should have a staircase from a dead end at about 11.25 meters, right, 11.25 meters. So, if you are extending your building, for example, in IIT you would have seen blocks, you will find helical staircases, this is the purpose. And the blocks, if you have seen block 2, 3, 4 etc., there is an extension beyond the staircase. This came later on. So, they could maximum keep the length from the extreme end corner of the room, from there it should be 11.25 because that is dead end, one cannot go, one cannot. So, where our transportation people, transportation labs are there in second floor, that is a dead end. So, from there the staircase should not be more than 11.25. So, that is the idea, right.